Hello friends, welcome back to my channel. AIM. My name is Vinay, teaching +1 +2 for past 17 years. In this video friends, we are going to discuss few questions from calculus, especially from limits, continuity, differentiability, K CET 2024 questions. Before going to solve, let's see friends how many questions are arised in 2024 K CET from this portion calculus. Limits, continuity, differentiability, there are 7 questions. Application of derivatives 5, integral 6, application of integrals 2, differential equations 2, totally 4. So total questions out of 60 friends, where we got here around 22 questions out of 60. 22 questions out of 60. It is more than 1/3 of the question paper friends. Very important section we are going to discuss. It is a series friends. Now today we are discussing limits, continuity and differentiability questions arised in 2024. Let's get into first question friends. In 2024, the first question is limit of √2 cos x minus 1 divided by cot x minus 1 as x tends to pi by 4 is equal to, our options are 2, √2, 1 by 2, 1 by √2. For these kind of questions, first let us apply limit directly. Now for this question, if you apply limit directly, what we are going to get friends here, √2 into cos pi by 4 minus 1 divided by cot pi by 4 minus 1, and here in the numerator cos pi by 4 value is 1 by √2 minus 1 divided by here 1 minus 1. Clearly we are going to get here 0 by 0, which is an indeterminate form. So in this case friends, we are going to apply a rule called L'Hospital rule for further simplification. What is this L'Hospital rule says? See, if you have a limit of function f of x divided by g of x as x tends to some real number a, and if you apply limit directly, and by applying limit you are going to get f of a divided by g of a. If this value is not defined, that is indeterminate, then L'Hospital rule says differentiate the numerator function separately and denominator's function separately, then apply the limit. That means keep the limit as it is. Differentiate the numerator function f dash of x separately, you don't apply u by v, denominator function g dash of x, and then apply the limit. If you get here f dash of a divided by g dash of a real number, so that will be your limit value. Again, if you are not getting indeterminate value, that is not defined, infinity by infinity, 1 by 0, 0 by 0, these kind of forms, then again we can apply the same process. That means you can again, for this function, limit you keep as it is and differentiate again, numerator separately, denominator separately, then apply the limit. Okay, in this case, if you get f double dash of x divided by a divided by f g double dash of a, again if you get a real number, stop here, that is your answer. If you don't get a real number, that is indeterminate form, again you are getting, again differentiate. How many times you want, you can apply. Okay, that flexibility is there in this L'Hospital rule. Now friends, for this given function, let us take the function here again. Let us write out limit √2 cos x minus 1 divided by cot x minus 1 as x tends to pi by 4. Now we know it is indeterminate directly if you apply the limit. Now we'll keep limit as it is. Apply L'Hospital rule. Differentiate numerator. √2 is a constant. We'll keep as it is. Cos x differentiation is minus sin x. I will write minus at the beginning here. I'll write sin x. Now minus 1 differentiation is 0 because it is a constant. Constant differentiation is 0. Similarly, in the denominator cot x is there. Cot x differentiation is minus cosecant square x. Minus 1 differentiation, again friends, it is 0. And as x tends to pi by 4. Now minus and minus will get cancelled. Now let us apply and check out. Let us apply limit now here. We have differentiated once. We have applied L'Hospital rule. Now root 2 into sine pi by 4 whole divided by cosecant square pi by 4, or you can write cosecant pi by 4 whole square, both are same. Now root 2 into cos pi by 4 value is 1 by root 2 whole divided by cosecant pi by 4, reciprocal of this, root 2 whole square. In the numerator, root 2 and root 2 will get cancelled. In the denominator, square and square root get cancelled. And your answer is here, friends, 1 divided by 2. So L'Hospital rule, using L'Hospital rule, finding limit of these kind of functions will become easy. Now how many times we want, we can apply L'Hospital rule. What L'Hospital rule says, if you have f of x by g of x, differentiate separately numerator and denominator. Keep it in mind, don't apply u by v here to differentiate. Then whatever you get, apply the same limit for that. You'll get a real number, that is your limit value. If you don't get a real number, again apply L'Hospital rule. So for this question, friends, option C is our answer, that is 1 by 2. Let's move on to the next one, friends. Now in the second question, we have differentiation of cos square of cot inverse root of 2 plus x divided by 2 minus x. Now here directly you can apply chain rule. Cos square is there. What chain rule says? Differentiate power, then base, then angle, it goes on. But in this case, see the options given, minus 3 by 4, 1 by 2, 1 by 2. Oh, sorry friends, here one of the option is minus 1 by 2, either B or C. Minus 1 by 2, plus 1 by 2, and 1 by 4. Now, if I apply chain rule, see there are so many different functions. I have to differentiate cos, I have to differentiate cot inverse, I have to differentiate root, then I have to differentiate 2 plus x by 2 minus x using u by v. It is a circus, friends. So we can use here trigonometric substitution so that we can simplify the function before differentiating. So for under root function 2 plus x divided by 2 minus x, for x we are going to substitute trigonometric function. Before that, friends, which are the results we are going to use here? Let us write down. The results we are going to use here is, first one, 1 plus cos x is equal to 2 cos square x by 2 submultiple angle formula, and one more result from the same submultiple angle formula, 1 minus cos x. So this can be written as 2 sine square x by 2. And one result we are going to use from inverse trigonometry, that is cot inverse of cot x is equal to x. This is the composition of function and its inverse. It is always identity function. So simply if you say identity function is what? Input and output both are same. Now let's go back, friends. Here we are going to substitute for under root function here, 2 plus x divided by 2 minus x. For x, what we are going to put, friends, here x is equal to 2 cos theta. So as and when you put x is equal to 2 cos theta, find theta value here. To find theta value, shift to here and then you will get cos theta. Then clearly from this, theta is equal to cos inverse x by 2. So at the end, if you want cos theta value, we will use it as x by 2. If we want theta value, we use it as cos inverse x by 2. Without substituting back substitution, we cannot differentiate because we have to get the function in terms of x. Now let us put this in under root function. Let us take only under root functions, friends, here. What is under root function? Under root 2 plus x divided by 2 minus x. So 2 plus x, in place of x we are going to substitute 2 cos theta divided by 2 minus 2 cos theta. In both numerator and denominator 2 is common. Once you take 2 common, you will get 1 plus cos theta divided by, if you take 2 common, 1 minus cos theta. 2 and 2 will get cancelled under root, and 1 plus cos theta can be written as 2 cos square theta by 2, and 1 minus cos square theta can be written as 2 sine square theta by 2. Again 2 and 2 will get cancelled, and what will you get here, friends? Under root cos square theta by 2 divided by sine square theta by 2. Cos by sine is cot, so we'll get here cot square theta by 2. Again square and square root will get cancelled, so this under root function now can be written as cot theta by 2. Let us take the function, friends. Now here, what is the function we have? Let us take it as y is equal to cos square of cot inverse root of 2 plus x divided by 2 minus x. Now we got the value of this. We'll write that cos square of cot inverse. This value we got as cot theta by 2. Now we are going to use here cot inverse of cot x. Cot inverse of cot x is x. So cot inverse of cot theta by 2 is cos square theta by 2. But friends, we know the value of theta or cos theta. Here we are getting cos square theta by 2. Again, we are going to use this result. Now cos square x by 2 can also be expressed as 1 plus cos theta whole divided by 2 you can take, otherwise 2 cos square x by 2 is equal to 1 plus cos theta. Then cos square x by 2 can be written as 1 plus cos x divided by 2. Now we use this here. I'll write it as 1 by 2, this constant in the denominator, and in the numerator what you have? 1 plus cos x. Here theta we have, we can write it as 1 plus cos theta. Now go back and see, friends, what you have? Cos theta is equal to, see here, cos theta value can be written as x by 2. We don't want this inverse function there. Directly we'll substitute cos theta value. Cos theta is x by 2. We'll substitute cos theta here. Then y will become half of 1 plus x by 2. Multiply half, you'll get half plus 1 by 4 into x. Now find differentiation. What is dy by dx here, friends? Half is a constant, differentiation is 0, plus 1 by 4 is a constant, keep as it is. Differentiate x, x differentiation is 1. So your answer is 1 by 4. This is how directly you can find this, friends. Our option is option D for this question. So keep it in mind, where these results 1 plus cos x, 1 minus cos x, and cot inverse of cot x to solve these kind of problems. Let's move on to the next one, friends. So here the third question is, the function f of x is equal to modulus of cos x is, let us read out the options. Option A, everywhere continuous and differentiable. Everywhere continuous but not differentiable at odd multiples of pi by 2. Option C is neither continuous nor differentiable at 2n plus 1 of pi by 2, n belongs to z. This 2n plus 1 of pi by 2, n belongs to z is same as odd multiples of pi by 2. Okay, both are same condition. And option D, not differentiable everywhere. See, these kind of problems are knowledge problems, friends. If you know facts, you can solve this problem. Now, what are the facts should be known to solve this problem? First one is, if f is continuous, then that implies modulus of f is also continuous. This is the first condition we should know. And the second one, you should know the domain of the given function. domain, and better to know the graph. If you know the graph, friends, directly you can write, is it continuous, differentiable or not. See, in the graph, if you have a free hand curve, and which is smooth means there is no jump in the graph, there is no vertex. See, for example, if you know x square graph is this, and also we know modulus of x graph is this. In this x square graph is a smooth curve, so this function is continuous everywhere, differentiable everywhere. Okay, if it is smooth. If you have a vertex like this, in modulus of x we have vertex, at this vertex the function is continuous, no doubt, there is no jump. But at this vertex it is not differentiable. Now we say it is not a smooth curve. Okay, so we have to see here the function is continuous or not. Just recall, friends, cos x function, is cos x continuous everywhere? How do you get the graph? Let's see the graph of cos x. The first one here we have at the top, friends, it is graph of cos x. See, this graph is smooth curve and continuous everywhere, nowhere there is a jump. It will continue. It starts from negative infinity on x-axis up to positive infinity. There is no jump, there is no breakup, the graph is continuous. At all real points, this cos x function is differentiable also, because there is no vertex, there is no real jump anywhere. So it is continuous as well as differentiable. I am talking about which function, friends? Cos x. Now let's see the graph of modulus of cos x. Before going to modulus of cos x, you have to see the graph of cos x here. From minus pi by 2 to plus pi by 2, the graph is above the x-axis. Pi by 2 to 3 pi by 2, the graph is below the x-axis. So what you can conclude from this? Whenever you have graph above the x-axis, the function is positive in those quadrants. Minus pi by 2 to 0, this is fourth quadrant. 0 to pi by 2, first quadrant, cos is positive, that's why the graph is above the x-axis. In second and third quadrant, cos is negative, so pi by 2 to pi to 3 pi by 2, we are getting graph below the x-axis. Got it, friends? Now let us move on to this question, which is y is equal to this function, y is equal to modulus of cos x. Now as we have modulus, it cannot be negative. So see, friends, that's why this graph is always above the x-axis. It is always positive. But what is the difference between this curve and this curve? See, here at all these points curve is smooth, but at minus pi by 2 it reverses. It is making a vertex here, and at plus pi by 2 also here, this is making a vertex. So at these points, where you are getting a point, it is not a smooth curve. At this point, the function is not differentiable. Which are the points we have here, friends? Plus or minus pi by 2. You move on further, again cos 3 pi by 2 value is also 0, cos minus 3 pi by 2 value also 0, so minus plus or minus 3 pi by 2, and it goes on. Integral multiples of pi by 2, modulus of cos x is not differentiable. Now let us go back, friends. See, it is differentiable. Option D you can directly eliminate, because we came to know it is differentiable at different points, only at minus pi by 2 plus pi by 2, or plus or minus pi by 2 plus or minus 3 pi by 2, or integral multiples of pi by 2. It is not differentiable, but this function is continuous, so option C also you can eliminate directly. Now option B, everywhere continuous and differentiable, you can eliminate this also, because at few points, say plus or minus pi by 2, plus or minus pi by 3, this function is not differentiable. So left out option is B. Our option B is the right answer for this, friends. Just know the graph so you can tick and move on for these kind of functions. This function is everywhere continuous but not differentiable at odd multiples of pi by 2. So option B is the right answer, friends. Let us move on to the next one. If y is equal to 2x to the power 3x, see friends, here in the base we have variable as well as in the exponent. In the base we have the variable x, in the power also we have variable. These kind of functions are called exponentiated function. What kind of function? Exponentiated function. That means the functions where in the exponent as well as base have variables. For these kind of functions, finding derivative at a point or whatever, it is directly impossible. See the options. Option A 2, B 6, C is 3 and A is 1. To solve this, we must go and take log on both sides for the given function. Without taking log, it is impossible to solve. Let us take log on both sides. 2 into x to the power 3x, and here we are going to use two results from logarithm. Log p to the power n, base can be anything, nothing is there means base is e. This can be written as n into log p. This one result we are going to use, and one more result, friends, we are going to use here, log m into n. This can be written as log m plus log n. These two results we are going to use before going to differentiate. Now let us take log on both sides. If you take log on both sides, we are going to get here log y is equal to log of 2 into x to the power 3x. Now first we are going to apply log m into n here. We'll keep the left hand side as it is and we'll simplify right hand side. Log y is equal to log 2 plus log x to the power 3x. First term simplified. Let us simplify the second term using one more property. The one more property here we are going to use is log p to the power n. In the power we have 3x. We'll write it as 3x into log x. Now friends, we have simplified. Now all variables are in the base. Now we can differentiate. Now let us differentiate with respect to x. By differentiating with respect to x, log y differentiation is 1 over y into dy by dx. Log differentiation is 1 over y. Y differentiation is dy by dx. We are applying chain rule. And what is the differentiation of log 2? It is not 1 over 2, friends. Log 2 is a constant. We know differentiation of constant is 0. So log 2, because it is a constant, the differentiation of log 2 is 0. Plus, we'll group here 3x as one function and log x as another. We'll apply u into v, product of two functions. What is differentiation of 3x? Differentiation of 3x is 3 and the second function will keep as it is. Plus, keep the first function as it is and differentiate log x. Log x differentiation is 1 over x. X and x will get cancelled. And what is remaining, friends? Let us write down what is remaining here. What is remaining? 1 over y into dy by dx is equal to 3 log x plus 3. X and x cancels. In the last term, what is remaining? Only 3 is remaining. First term is 0. Now in the right hand side, we are going to simplify right hand side. Dy by dx is equal to, what will you get? Shift y into right hand side, y into 3 times log x plus 1. What is y, friends? Y is 2 into x to the power 3x into what else we have? 3 times log x plus 1. This is what our dy by dx, differentiation of the function. But they are asking you to find dy by dx at a particular value, x is equal to 1. Let us substitute this value in the differentiated function. 1 to the power 3 into 1 into 3 of log 1 plus 1. Friends, what is log 1 value? 1 to the power anything is 1. 2 into 1 into 3 is 6. Log 1 value is 0 plus 1. So from this we'll get our answer as 6. So to solve this problem, we have to take log on both sides, and we are going to use one or two properties of logarithm. Our option is option B for this problem, friends. Let's move on to the next one. Now we have different kind of problem. Let the function satisfies the equation. See the equation here. F of x plus y is equal to f of x into f of y. This is the function given. For all x and y belongs to R. All x and y are real numbers, where f of 0 is equal to not. F of 0 is not equal to 0. If f of y is equal to 3 and f dash of 0 is equal to 2, then f dash of y is. Now here real function is not given, only they have given equation f of x plus y is equal to f of x into f of y. We cannot introduce any functions, friends, here. Now for x and y we have to choose real values. How to decide which real value should be chosen? We have to search in the given question itself what are the values of x given. See here, they have given f of 0 is not equal to 0, so x value they have taken here 0, and in one more equation f of y is equal to 0, x value they have taken here 5, in one more again 0, in one more again 5. Okay friends, now we can think of putting x is equal to 5, y is equal to 0. Otherwise, putting x is equal to 0, y is equal to 5. That is left to you. Okay. Now, here, what are the things we are going to use? We need to find f dash of 5 at the end. For this, we are going with first principle. What first principle of calculus says? F dash of x is equal to limit of f of x plus h minus f of x divided by h as h tends to 0. Okay, so from this what f dash of 5 will be? Limit of f of 5 plus h minus f of 5 whole divided by h as h tends to 0. At the end, this is what we are going to use. Now before that, let us find out the values we require for this by putting x is equal to 5 and y is equal to 0. Let us put directly, friend, these values for x and y. Put x is equal to 5, y is equal to 0. We are going to get f of 5 plus 0 is equal to f of 5 into f of 0. So in the left hand side we are going to get f of 5, in the right hand side f of 5 into f of 0. F of 5 value they have given 3 and 3, so these two will get cancelled. What will remain here? F of 0 is equal to 1, which is not equal to 0. Now we got f of 0 is equal to 1. Okay friends, let's go now. Now we got two values, f of 5 value as well as f of 0 value. And what else they have given? They have given this value also, f dash of 0. F dash of 0 is how much? 2. Now we'll go with f dash of 5, friends. Now f dash of 5 can be written as limit of f of 5 plus h minus f of 5 whole divided by h as h tends to 0. Now for the first function, we'll apply using the function given in the question. In the question what they have given, f of x plus y is f of x into f of y. The same we are going to apply here also. We'll apply that, and we are going to get f of 5 into f of h minus f of 5 whole divided by h as h tends to 0. Now f of 5 in both we have, will take out common, and f of 5 value is 3, and it is a constant we can take out of the limit. I will write directly here f of 5. And what else is remaining? Limit of f of h minus 1 whole divided by h as h tends to 0. Now again we are in trouble. We don't know the value of this limit, but they have given f dash of 0 value. Let's check out what is the value of f dash of 2, f dash of 0. That value is 2. Now again, using first principle, this f dash of 0 can be written as, how will you write? It is limit of f of 0 plus h minus f of 0 whole divided by h as h tends to 0. So clearly friends, here f dash of 0 can be written as limit of 0, f of 0 plus h is h, and f of 0 value we have found here friends. F of 0 value is how much? F of 0 value is 1. So we'll put that value here. Then limit of f of h minus 1 whole divided by h as h tends to 0. Now this limit value becomes, what is the value of this limit? F dash of 0. So f dash of 5 can be written as f of 5 into f dash of 0. Now f of 5 value is 3 and f of f dash of 0 value is 2, and our solution here is 6. Let's see friends, our option A is the right answer for this. This is how we can solve these kind of problems. Just choose the correct values for x and y, then think what they are asking, accordingly which property we need to use to solve the problem. Let's move on to the next one friends. A problem is on determinant. Two properties, one is determinant property and one is derivability. Now A is given determinant of x1 1x, and B is given determinant of x1 1 1x1 1 1x. Now you need to find dB by dx, and you need to verify it is equal to 3a minus 3b, 3b plus 1 minus 1 minus 3a. So all are related to either a or b. Now first let us differentiate b. Before differentiating b, two methods are there friends. We'll go with first method. Let us expand this along r1. Let us expand this determinant along r1. We must know the sign convention of the element. First element sign convention is plus, second one is minus, third one is plus. Now by expanding this along first row, plus x into determinant of, leaving first row and first column, what are the elements we remaining there? x1 1x, take it as determinant of order 2. Then go with the second element here. Second element is 1 and the sign convention is minus 1. Leaving first row and second column, what are the values we are going to get here? 1 1 1x, take it as 2 by 2 determinant, and the last term is plus 1. Leaving first row and third column, the elements remaining are 1 x 1 1. Now from this we'll get x into, multiply diagonal elements, x into x square, then take minus, multiply non-diagonal or diagonal elements, one more set of diagonal elements, 1 into 1 1, minus 1 of 1 into x is x, again minus 1 into 1 is 1, plus 1 of 1 into 1 is 1, minus 1 into x is x. Now simplify this friends, multiply everything, you will get x cube minus x plus 1 as plus 1 minus x. So we got b here. B is what? X cube minus x minus x minus x, you'll get minus 3x plus 1 it is plus 2. Let us differentiate this function. What is b we got here? Let us write down again. B is equal to x cube minus 3x plus 2. I need here dB by dx. Now dB by dx is 3x square minus 3. 2 is 0. So if you take out 3 common friends here, then you will get x square minus 1. So this is the simplified form of dB by dx. Now let us verify the first option. First option is 3 into a. Now find out determinant of a value here. What will you get? X into x, x square minus 1. So x square minus 1 can be written as a. So here x square minus 1 is there, that can be written as a. So our option is 3a. So our option A is the right answer for this. Friends, whenever a determinant is given to us like this, determinant x1 1, whichever the determinant 1x1 and 1x, whatever the determinant is given to you, to find dB by dx, we have one more method, that is differentiate first row, keep the remaining two row as it is. Differentiation of x is 1, differentiation of 1 is 0 and 0, and remaining 2 you keep as it is, 1x. This is one more method of finding derivative of determinant. Keep first row element as it is, yx1 1, and derive the second row element. Derivation of 1 is 0 and x is 1 0. Keep the third row as it is, 1x, and the last term keep first two rows as it is, 1x1, and differentiate the last row, 0 0 1. You expand these three, friends, and add, you are going to get 3 times x square minus 1. This is one more method of deriving any determinant given to us. Okay, so for this question, friends, option A is our right answer. Let us move on to the next question, friends, which is the last question in this question paper. The value of c in 0, 2, we have to find a value of c which lies between 0 and 2, satisfying the mean value theorem for the function f of x is equal to x of x minus 1 whole square. The domain of this function x belongs to closed interval 0, 2. Now they are talking about mean value theorem. We have two mean value theorem, Rolle's theorem and Lagrange's mean value theorem. So mean value theorem means they are talking about Lagrange's mean value theorem. Now to satisfy any function is satisfying Lagrange's mean value theorem, that means the function must be continuous in the given interval and must be derivable in the given open interval. See, what kind of function is given to us, friends? It is a polynomial function. Clearly it is derivable as well as continuous at all real points, but it is given in the interval 0 to 2. It is continuous everywhere, but at the end points the function is not derivable. At any interval end points function is not derivable, it is continuous. So for the given function f, can you conclude this? F is continuous in 0, 2, because it is a polynomial function, it is continuous everywhere. Also the second point, f is derivable in the open interval 0, 2, because at the end point it is not differentiable as interval is given to us. But we know polynomial function is derivable at all real points, but when the intervals are given at the end points it is not derivable. Now at the open interval it is derivable. So these two conditions the given function is satisfying, that means it is satisfying Lagrange's mean value theorem. Then this theorem says there exists a value c which belongs to open interval 0, 2 such that it satisfies an equation. The equation is f dash of c is equal to f of b minus f of a. B means here the end term of the interval, a means the initial term of the interval. Now here directly we will take f dash of c can be written as f of 2 minus f of 0 whole divided by b minus a. B value is 2, a value is 0. Let us substitute and find the value of this, friends, f dash of c value. Here f of 2 we need to find, put 2 here in place of x, so it is 2 into 2 minus 1 whole square, that is 1 square into 2 is 2, minus, put 0, x is 0, 0 into anything is 0, we'll put 0, divided by 2, so value is 1. So we are getting f dash of c is equal to 1. But what is f dash of c? We don't know what is f dash of c. To find f dash of c, again we'll take this function, differentiate, and in place of x put c. That means let us take the function here, f of x is equal to x times x minus 1 whole square. Let us differentiate this. Before differentiating, let us expand this, x square minus 2x plus 1. Now multiply x cube minus 2x square plus x. Now we got f of x. Let us differentiate this. Let us find f dash of x. So f dash of x is 3x square minus 4x plus 1. Now put c here in place of x. So we'll get f dash of c. What is f dash of c? 3c square minus 4c plus 1, and we know this is equal to 1. F dash of c is equal to 1. So we will get here, friends, 3c square minus 4c plus 1 is equal to 1. On either side 1 and 1 will get cancelled. So we'll get here 3c square minus 4c is equal to 0. Take out c common here. If you take out c common, then we will get 3c minus 4 is equal to 0. This gives you c is equal to 0 or c is equal to 4 by 3. C is equal to 0 is not possible because 0 does not belongs to open interval 0, 2. C is equal to 4 by 3 is possible as 4 by 3 lies in the interval 0, 2. So for this question, our answer is 4 by 3, that is option B. Now friends, these are the questions arised in the question paper of 2024 K CET. If you like this explanation, friends, please like, share and subscribe. Hit the bell icon for the further notification. If you want to explain any concept, please let me know in the comment box. I will explain it for you. Thank you. Bye.